Hello, everybody. This is Kevin Sloan, director of the University Rover Challenge. I'm excited to be back with you again. Excited to welcome back a couple of distinguished URC alumni, a couple of folks that were certainly no strangers to the competition, participated for a number of years, and they're no longer students. But I thought it'd be great to get the perspective of some of these alumni, give them a chance to think back on their experiences as students, help prepare them for the next steps of their careers, and any advice they might have for some of the students. So I'll introduce my two guests. We'll start with Neil. Neil, you want to tell us a little bit about yourself, who you competed for, and what you're up to now?
Sure. I'm Neil Hinckley. I was on the BYU Rover team for a long time. I actually participated in the first URC ever, which was a lot of fun. So now I'm working actually for an architectural engineering firm, which I never thought I'd end up there, but it's where I am. It's been a lot of fun. I also volunteer as a judge now at the URC, which is also a lot of fun. Kind of missing it this year, but what can you do?
Yeah, I think we're all missing being out in the field this year, but it certainly has been great having the perspective of a former student working with the judges. Give us a little bit of that student insight, or a former student insight at this point. But turn it over to Oliver.
Yeah, so my name is Oliver. I was part of the McGill robotics team at McGill University in Canada, in Montreal. And I've been participating in the University Challenge for, I think I've been for 3 years, in 2015, 2016, and 2017. So a bit later than what Neil. But yeah, I've been part of this team. It's been a tremendous experience, and now I'm a graduate student at the University of Toronto in Canada. And as part of my thesis, I'm also working in collaboration with the NASA Jet Propulsion Laboratory. So I'm still in the vein of planetary navigation. So as you can guess, and I guess we'll talk about, URC was a tremendous and useful experience in my case. So yeah, happy to be here and talk to you guys.
Yeah, thank you guys for taking the time, and certainly glad to welcome you back. So it's always great seeing students as they grow up, graduate, and see the success that they're able to have in their careers. And certainly is true with both of you. You've been some of the, it's been great just being able to keep in touch with you as you've moved on. So Neil, I was talking with a couple of the other judges earlier, and we were talking a little bit about where the competition started and, really the state of the technology. And, teams that first year, I don't think they knew what to expect when they showed up. And certainly as, judges and staff running the competition, I don't think we even knew what to expect that first year. But, what are your thoughts on having been able to see the competition evolve over all these years?
It's really been pretty amazing. I mean, that first year we showed up with a box with some RC car motors strapped onto it and a tablet computer inside that overheated almost immediately. And, just going from nobody knowing what the heck's going on to now where we have, honestly, some really sophisticated robotics showing up at the competition every year. It's been really pretty incredible to see that transition as, teams have learned from past experiences and also from other teams as, kind of shared that experience between them.
Yeah. Now,
when was the first year of URC?
So the first competition was 2007. So we launched it in late summer 2006. And Neil, how many years did you compete? Because I think you actually hold the all-time URC competition record.
I don't know if that's something to be proud of, since it says something about how long I was in school.
You had something to stick around for.
Yeah, I think I competed in at least 6 years.
It's a pretty big accomplishment right there. So I'm actually a little disappointed in myself that we haven't made you a special badge for this. So I think maybe we'll need to have a special ceremony in 2021 when we're able to have the competition out in the field again. So you were really able to see the competition grow during its early years from the perspective of a student. And then Oliver, when you came on board was really when, that was right around the time URC became the tremendous international field of teams that we see today, where, it's routine that we see. This year we had, I think, 93 teams registered at the beginning of the year, but having to go from such a large field of teams and work down to 36 teams. So you guys kind of reflect the perspectives of two different eras within URC. It's amazing to think we've been around long enough that we have eras of the competition now. But I think it's interesting, the early years. You talked about having to strip RC cars for a lot of your components because a lot of the technology just wasn't available. You didn't have off-the-shelf motor controllers or anything else at that point. And then fast forward to now, we see teams routinely printing their own custom electronics boards, and that's almost become standard. But then they're also able to offset that where they need to go out and purchase commercial products. Now, Oliver, in your time, what was really the state of the industry? How easy was it to go out and find components? How much did you have to really rely on in-house production?
Yeah, so we were at the very beginning, in our case, I think it was pretty easy for us to just find off-the-shelf components and set up something real quick together. That might not be the most optimal solution, but that would be enough for quick prototyping and testing really early in the year. However, in our case, I don't know if Kevin, you remember, in our very first year, we went for a Hail Mary a little bit, and we tried to design our own electric circuit boards, so our own PCBs. Some of the team members, even though it was our first year designing a rover, some of these team members were part of another project within McGill Robotics, which was to design an autonomous underwater vehicle the year right before. And we were hoping to actually push our ability to design PCBs, for example, with the rover. But the thing is, an underwater vehicle and a rover are very different. So we betted everything on our electric system, not having too many experiences. And the day right before competition, or 2 days before, we just shorted all of them at once. We didn't have that many circuit protection system. So we got to URC and we bought a bunch of off-the-shelf components. We're trying to piece our rover back together to have something working properly, which we did a little bit at the very end, but it was a very tough learning experience. And moving on the following years, we made a lot more use of off-the-shelf components, which turned out to be really, really useful, and just focus our efforts on designing custom PCBs where we thought there would be a huge benefit in us having to design our own PCBs. So I would say it was pretty half and half. And we were pretty free to design our own components, whether they're PCBs, mechanical system, or even code up our own software. So I think we had the luxury to choose whether we wanted to either do our own custom thing or choose off-the-shelf components. There were so many choices out there.
Yeah, you mentioned some of those failures in the field, and those are painful lessons to learn. It's painful to see teams learn those lessons the hard way when they see failure in the field. And I'm not sure you've really earned a URC badge of honor until you can distinctly recognize the smell of burning silicon when you burn out a chip. It's a distinct smell that once you know it for life.
Yeah, the magic smoke.
Yes, exactly. The magic puff of smoke is never a good sign. But reflecting back on your time with URC, how did that help you just in terms of your overall educational experience in college? How did that compare with what you learned in the class? Now, obviously, you go to college to get a degree. The classroom, the classes, that core content is, obviously immensely valuable. But how did URC compare with that?
I'll go ahead first. In my case, I don't see as URC to be a replacement or something to compete with classes, but more as something complementary to it. In classes, you'll learn a lot about theoretical concepts, and you might have some small-scale projects, and you might participate in laboratories, which have so many controlled environments around your project to make sure that you get proper results and something representative of what you've learned in class. But when you start working on a project like designing a rover for URC, you realize that you don't have the luxury of having all these controlled environments around you, and you have to contend with a lot of challenges that are thrown at you. In our case, I felt like URC provided an amazing opportunity to not only apply our design skills, at the preliminary design phase, but also learn a lot about when it was time to manufacture our components, putting them together, a lot of systems engineering work, a lot of issues coming up from putting two pieces together that you were sure would work properly together, but they don't. And then later on during the year, you want to test as much as possible in order to prepare for the competition itself. And there are no classes that taught us ever throughout my degree how to properly bring a whole project to term like that, test it all out and having a good systems engineering plan, making sure all of your constraints and all what you wanted to achieve initially early during the year are being achieved. That being said, once you make it to competition, there are a lot more issues coming up. Just the transportation of your equipment is extremely hard. How do you make sure your equipment gets to the competition without being damaged? That's a huge, huge challenge. Once you make it to competition, how do you make sure that you don't short out your equipment, because the desert is so dry, there's so much static electricity all over the place, and you might just short out your components like that. So how do you prepare for this in advance during the year? Some experiences were literally, I just keep carrying those experiences throughout still today, throughout my education and my career. But I would say that what was the most useful in our case was literally just bringing robots outside of a controlled environment, testing them, and ultimately making it to competition and seeing how equipment transportation and literally deploying your robot in the actual field was a huge learning experience.
Well, I think you've really hit on something that we always joke, and teams so they've come out for their first year, they never fully embrace it, but URC is a logistics competition with a little bit of robotics thrown in.
Right.
Certainly, great perspective. Neil, what about you?
Yeah, I really agree with a lot of that. I think that as Oliver mentioned, in classes you learn the theory, but you don't really learn how difficult it is to apply that to a real situation. So with the rover, you go into it with lots of big ideas, what you want it to do, and how you're going to design this amazing system to do that. And then hopefully somebody reins you in and makes you realize you don't have time to do that. And you have to kind of think of, okay, so what's the most important thing I can do this year to make our rover better in the time that we have? And I think that's something that you don't really learn in classes very much, is the idea that you have to work within the constraints you're given with any project. And
it's the tyranny of the schedule.
Yeah, it's usually a scheduling issue. But there's also budget constraints and other things like that you have to work within. And you also have to realize that the most important part is actually testing it, not designing and building it. Because if you design and build it, but you never test it, it's going to fail, pretty much guaranteed. Especially once you get down into the desert, like Oliver mentioned, it's a completely different environment. There's dust everywhere. It's windy. It's hot. There's lots of static. The sun is shining, which you wouldn't think that would make a big difference, but it does in a lot of. So these are the kinds of things that you don't pick up by sitting in a classroom learning the theory. It's kind of that hands-on application that forces you to learn some of the more difficult parts of managing and building a project, as far as scheduling and constraints go.
Yeah, I would say another thing was the ability, as silly as it may sound, the ability to talk to other participants and meet other teams was a huge, huge learning experience. Not only not just making it to the field on its own. This was a huge learning experience, but also just seeing everyone's preliminary design review videos, and just seeing all the different design philosophies that were going behind accomplishing the same task. Some teams might have different expertise and choose a specific set of solutions. Some people might have been taught some specific concepts and chose to go with a totally different solution. And seeing all of that is just this huge. It's just an amazing way to see how the different design philosophies behind designing a rover. And especially once you make it to competition, just meeting all these participants is amazing because you're just broadening your network. You're still in touch with them. I'm still in touch with a few of those participants. When I was still a participant in URC, we would often communicate with each other throughout the year and just asking, hey, like, you guys did this last year. How did you solve that challenge? And people were very friendly about it. And just being able to put our work on display amongst all the other teams and being able to help each other was also a huge learning experience. That's something that we don't really, the whole collaboration part of the project is not something that we're really being taught in class either. In school, it's a very individual experience usually, but if you can get your hands dirty and get involved in teams and ultimately also interact with other teams from other universities, I think it's amazing, and that's something that we were not exposed to by just sitting in classes.
Yeah, the interaction between teams is always something that amazes us, and it's one of the things that as judges, it makes us motivated, just seeing the attitudes and the energy of the students. But you mentioned different implementations of certain pieces of technology, and I always think of your team is a great example. And with the rovers, I think it's very easy to think of the traditional 6-wheeled rocker bogie suspension. It's something where if you talk to somebody who works is familiar enough with robotics, they know rocker bogie suspension. I think the initial thought is there is a singular type of rocker bogie suspension, but then you watch across the spectrum of rovers, and when you have hundreds of rovers that have been built over the years, you start to actually see different variations on what can be a traditional rocker bogie. And I think at McGill, you called it the double lambda. There was a double lambda in there on that variation, but that was a great example where it wasn't a traditional rocker bogie. It carried a lot of that influence over, but you see different variations. And I think teams kind of across the board are able to collectively learn by each being able to test out different permutations on things, which I think is really exciting.
Yeah, well, something that I really enjoy seeing is kind of the difference that you see between different regions even in the world. So some of my favorite teams to watch are those that have very limited budgets. And so they come with this rover that's using windshield washer motors and all sorts of unusual components that we wouldn't even think about in our team. And they still do very well. I mean, it's not that there's one way to accomplish this. There's lots of different methods and means of accomplishing that same goal.
Absolutely. Absolutely.
Yeah, now, I'm sorry. You get to a point where, starvation almost fuels creativity a little bit. You need to find solutions like that. But also another thing we learned is once you design, and I guess that's also something, Neil, that you realize at some point, you get to a point where, of course, you want to design nice mechanisms, like you mentioned, the double lambda rocker bogie we've put together, but also you want to design something that's, you want to stop perfecting a design and also just stop at some point and settle for a specific design. The worst enemy of, perfection is the enemy of good enough. And ultimately, you want a rover that can perform well for the competition environment for Utah. And this was a double-sided blade for us. So we could come up with really cool designs like that. But ultimately, a robust design will win over a very fancy and weak and not very robust design. So there's a trade-off here where you really want to be creative and come up with new ideas, but at the same time, you want to make sure you really test them and you really want to make sure that they're they will perform well at competition. Sometimes a very simple idea will go a long way compared to a very complicated and intricate idea.
Yeah. Now, switching gears a little bit, you both were able to serve in team leadership duties over the years. So that's an experience that not every URC competitor is able to do. And, in some cases, I think there's certainly not as much interest in filling that, or it's perceived as a less exciting role. But certainly there are a lot of folks that are able to embrace that role and really learn a lot from it. And, for me personally, being a little bit further along in my career and removed from my university days, I feel very lucky to have had some leadership roles in student organizations back when I was in undergraduate. And the opportunity to get some of that experience very early on before you really get far into your career is something that I think is really unique, and I think a lot of times can help you advance in your career. But I'm curious from each of you what you took away from the leadership side of that experience and how it's helped you in your career. And I'll start with Neil, and I think it's kind of interesting. You mentioned that you're working for an architectural engineering firm. Architectural engineering is certainly an area where I think project management gets a lot more focus and attention. So definitely interested for your thoughts on this.
Yeah, it's been really interesting from that perspective. As in that leadership role on the rover team, you have to get used to managing a lot of different people with different schedules, demands on their times, things like that. And I think that really applies a lot to real world jobs. And for example, where I'm working right now, I'm working on probably 12 different jobs right now, and having to realize, everyone's kind of in that same situation. Most people aren't just working on one or two things. And so they all have different demands on their time. And so you're having to work with them, schedule things out ahead of time to make sure that, they can actually be available for a certain meeting, or they can hit a certain deadline with everything else that's going on is important. And that's something that you learn a lot in school, because, people are in different classes, they're in different groups. You're having to work around everyone's different schedules in that same way. And I think that also just the idea of how long it takes to do certain tasks is something that's really important, and something that I really learned a lot about working on the rover. You have to figure out, okay, we need to have this done by this date because we have to do this testing, we have to plan for some revisions, we have to plan for all this other stuff beyond just the base design. And that's something that we see a lot in architectural engineering, is that, we'll come up with kind of a preliminary design, present it to the client, they'll have their comments, they request these changes, and we kind of go through those same iterations.
Yeah, and you mentioned the different demands on people's times, and I think there's something that's unique when you're able to have a leadership position within a student organization, because a student organization, unless you're doing it as part of a senior design project or something like that, for the majority of teams, it really is a volunteer experience, and any of those students, they can choose to prioritize their classes over the project at any point in time. So it teaches a different management skill when it is in that volunteer sense. And so you have to find ways to really keep everybody motivated, engaged, make sure that it's a rewarding, fulfilling experience. And I think that's different than what the perception of management and leadership are. And I think a lot of times management and leadership are used interchangeably when they're certainly very different things. And I think folks that haven't had a chance to sit in that seat, they think that a strong leader is a strong manager and somebody that rules with an iron fist and barks orders and makes everybody else miserable. And when you get into the real world, you can see the managers and the leaders that come to an organization with that mindset, and they are very rarely successful. It's rare that you can, in a real world setting where everyone's working on a high stress project with multiple priorities and demands, if you can't think of it from that leadership mentality where you're constantly trying to inspire, motivate, encourage, and support, the idea of servant leadership, I think those are great things that you learn from the student perspective, that I think it really gives you a unique opportunity once you eventually are able to move into management and leadership positions throughout your career later on. Something I think is something that I'm grateful for having that perspective as I've moved throughout my career. How about you, Oliver?
Yeah, I totally agree with all of what you guys said. The thing is, leadership, I guess, is very personal to different individuals. So people will have different leadership styles. But something that worked really well for me is to realize that in my case, as being a leader, I decided to spend a lot more time listening and taking decisions. Yeah, of course, at some point you need to take a decision. You're leading the team, and when there's a bit of debate left and right about a certain decision, then ultimately you'll need to take a decision. But you need to understand that a team is a single organism made of subcomponents interacting with each other, and these are all the members. And if you don't listen to that, just like if you don't listen to your own body, for example, things can go wrong. So as a leader, I spend a lot more time listening to others than taking decisions. I would say I spent maybe 60% of the time just listening to what people had to say before saying anything, and basically sharing my opinion. Another thing we had at McGill Robotics was this mentality of team before machine, which was basically trying to grow a healthy team culture among all the members by once in a while just taking a break from designing the rover and doing all the hard work and just having some fun. Whether it could be as simple as just having dinner together, or organizing a work session during the weekend and just ordering pizza for everyone, or even just taking a day off during the weekend and do some sort of activity or go to the movies. These might seem insignificant at first, but just having 2 or 3 members that were not talking to each other just because they were on different sub-teams, starting to talk with each other, and then you see that the whole team is kind of coming together by doing multiple of these activities, and you get to a point where you have a healthy team, and ultimately we believe that it led to a very healthy machine, and a nice robot, and just having an all-around really nice team to work with.
Yeah, and you said team before machine, and I don't think I've ever heard it captured so well. That really is, a great takeaway, and certainly something I hope a lot of the current students who are listening really take that to heart. And it reminds me of, a little bit earlier in my professional career, I worked with a really well-regarded systems engineer who had been in the industry a long time. And one of the things that he really tried to preach was that one of the missing components of systems engineering that's never talked about, but really sets apart successful systems engineering, is empathy. And without empathy, which really brings in that human side and understanding the team, the human aspect of it, and being able to put yourself in a different individual's shoes to better understand their perspective. That's really what helps the whole organization and the whole project come together exceptionally well.
Yeah, there's I guess another thing that I learned was that leadership is not necessarily just taking decisions all the time. I met so many people throughout this experience of designing rover. We had mentors and people from the industry coming for our design reviews, and very often they would literally just tell us, "Hey, I don't know. That's a good question. I don't know." And when you're in a leadership position, it's okay to just say, "Oh, that's a good question. I'm not sure. I don't know. I'll investigate that further." But very often people will try to come up with answers or stuff like that, but it's just okay to not know. And being a leader is not necessarily up to whoever's in charge of the team and leading it. Anyone can be a leader inside of their respective teams. Something as simple as just being punctual to team meetings, or taking initiative if there's a task that no one wants to do, and just be like, "All right, look, I'll do that tomorrow. That's fine. I'll take care of it." Or just ask questions and just interact with your team members is a nice way to just set the example and lead by example like that. And I think it's up to anyone as part of the team to also be leaders. Yeah.
Yeah, I mean, it's clear, talking with you guys, it's great to see how much you've really been able to take away from that. And I certainly love hearing how passionate you guys are, even now, reflecting back and talking about your experience with the teams working through this effort. 2020, unfortunately, the finals weren't able to happen this year. So, one of the things I hope we're able to pass on to teams through these videos is help set them up for success in 2021. And we really rely a lot on kind of that continuity of knowledge that passes down from upperclassmen to the underclassmen as they think about the turnovers each year. So, hopefully we're able to provide a little bit of the insight that'll help all the teams as they prepare for 2021. I'm curious if you have any, any parting thoughts, any last pieces of wisdom that you think is important for teams who haven't actually gone through that final stretch of the competition. All the teams made it up through the system acceptance review milestone. So they got to the point of largely having fabricated rovers, but of course, then that's when the hard work begins as you start to think about and prepare for the competition. So what are some great takeaways that you pass on to those teams and students who haven't actually attended the competition before?
So kind of going off a little bit of what Oliver mentioned earlier was, take care of yourself when you're at the competition. It's hot, it's dry. Please don't collapse anywhere. The competition can be a really grueling experience. A lot of the times you'll show up and something will go wrong and you're in the middle of nowhere, you can't get parts. And I know that I spent more than a few nights awake trying to piece together solutions to a problem that had cropped up. And, that's valuable experience too, and that you're kind of learning that, sometimes you're going to have to put in a little extra work. But it doesn't mean you do it at the sacrifice of yourself and what you can do in the future. You need to make sure that you're ready for whatever comes the next day too.
Yeah, I don't know if it's, I mean, I don't want to encourage, social gathering and stuff like that, but I think any team that has a functional rover right now, I would just encourage them to hold their own mini competition internally, designate people to have, to be judges and designate people to be in charge of the rover and literally just stick to a schedule and just try to simulate as best as you can a competition field. Just build up your own props, something really simple. If you, for example, for the service panel test, just put together a couple buttons and switches and I haven't seen the rules this year. I'm not sure what they were expected to do, but hold on your own small competitions. And also, I think as sad as it is, I think it might also be a great opportunity to start recruiting new members earlier than initially. Like Neil mentioned, the competition itself is a grueling experience. It's going to wear you down to the bone. You'll be so tired that in our case, we used to take maybe a couple of weeks off right after competition just to settle down and cool down. But in your case, maybe you could, to all of the participants that were hoping to go to Hanksville this year, maybe they could start recruiting as early as possible and start training a new generation of members earlier than usual, and hopefully get people more on board with the project. Because sometimes when you're on a tight schedule, it might seem like a very heavy chore to having to train new members and bringing them on board because you could be doing something else. But a single team member will go really fast, but a whole team together will go really far. And that's something that I've learned. So if the sooner you can start training new people, the sooner you can bring people on board and show them what the rover can do and how your team works, I think will be a really, really nice time investment for the upcoming year. So yeah, that's what I would suggest.
No, that's all tremendous advice, and certainly there will come a time where teams are able to get back together and actually have access to labs and rovers again. And so, thinking through how you can do testing that simulates the competition process as much as possible is a great starting point. And, in the meantime, we're all limited to using technology, connecting with each other over video conferences, but that's a great opportunity to, again, focus on the people, focus on making sure the team knows each other and that you have good solid plans for how you're going to approach the work before you get back to campus and start diving in headfirst at things. This was something I think we had talked at the beginning. We were going to do just a short, maybe 15-minute conversation here, but you guys have so much wisdom with the two of you, and think about the number of years of competition that you encompass just between the two of you here and the lessons that you've learned. I really appreciate you guys taking a little bit of time to pass this on to the students. I've certainly enjoyed talking with you. Always I'm excited anytime I get to talk with either of you, especially having seen you guys go through your undergraduate days and seeing everything that you guys have taken away from the competition. But I think we'll wrap it up here. I'm sure we could keep talking for hours. But again, hey, thank you guys very much for taking the time, chat with me, pass on some of your knowledge to the students. So it really is invaluable. And to everybody watching, thanks for staying with us. And again, I'm Kevin Sloan with the University Rover Challenge, and we will see you all soon.
All right, see you guys.